Hello ladies and gentlemen, today we're going to be learning about vectors and scalars. Now, physicists use lots of numbers, and numbers is basically the foundation of math, and math is the language of science. Now, where vectors and scalars come into place is this very fact that when you're talking about a certain number, vectors and scalars help to clarify exactly what kind of number you're talking about. If you're a little bit confused now, that's okay. We're going to clarify the differences between vectors and scalars in the upcoming slides. So if I were to describe something in my everyday life, for example, if I were to tell my friends, hey, I'm about to go to a meeting 150 miles away on the thruway, at that moment, my friend will know that I'm 150 miles away on the thruway. Okay, so if that thruway is going west, that's 150 miles going to the west. You know two very distinct things. One, how far I'm away, and two, in what direction I'm heading. Okay, numbers and direction. That's all you need to know for vectors. Scalars, on the other hand, is just a number. Okay, the number is what we're going to call from here on out the magnitude. The mass of an object is an example of a scalar. If I were to tell you that my pencil weighs 10 grams, then that means that the 10 is the magnitude and grams is the unit. And if I were to tell you that my pencil has a mass of 10 grams to the north, that actually makes no sense. Just say it and it sounds silly. If it sounds silly or if it doesn't make any sense at all, then you know that you have a scalar. Right? So if you add a direction to a number and it does not make any sense, then you have a scalar. A vector, on the other hand, it makes sense once you add the direction. Let me take that out of the way. For example, a vector is a quantity that has both a magnitude and a direction. For example, if I were to tell you that I am running 7 meters per second to the right, you'll know exactly how fast I'm going and in what direction I am headed. Now, in order to draw a vector, all you need to do is able to draw an arrow. The arrow head is pointed in the direction of your direction, and the arrow length denotes the magnitude. For example, on a graph or on a drawing of any sort, if you were to tell me that a cheetah is running at 60 kilometers per hour and we're trying to represent that with a vector, we would draw a big arrow. If we were to compare it to a snail who is going only 2 centimeters per day, that would be really, really small. Okay. Now, in order to write a vector, all you have to do is write whatever variable you are using. In this example, we have it as force, and draw a tiny arrow, like a little hat, right on top of the variable. All right, that arrow denotes that it is a vector. Now, if we are talking about force, the magnitude, all you have to do is write the letter F, or put the letter F in the absolute value symbol. That tells me that you're talking just about the number, okay, and no direction. Now, when we are drawing vectors, we have to use this method called the tip-to-tail method. In this example here, let's take a look at F1 plus F2. In order to add the two together, you have to get the tail of the first vector, okay, where the arrow is, and attach it to the tip of the second vector, or the other side without the arrowhead. And if you add those two together, what you see is a bigger arrow, and that's what it is. Okay? Now that's if it's going the same direction. Now if it's going in opposite directions, as shown in the second example, you do the same thing. You draw the first arrow, and where the arrow head ends, you draw your second arrow. Okay? And your result is whatever it looks like. Well, now we're going to do a little bit more work on that, so if you're confused now, just bear with me. Now, a couple of things that you must know when dealing with vectors. Okay? Remember, vector has two things. Whoa. Magnitude and direction. So when your vector is going to the left or down, okay, let me get my pen. When your vector is going to the left or down, we're going to put a negative in front of that magnitude. For example, if I were to say we are going 4 meters per second to the left, I'll just put a minus there, compared to 15 meters per second to the right. Then there's a positive. Nothing's there, I mean it's positive. Okay? Or if I were to tell you that I'm going 12 kilometers south, I would just put a negative symbol there, compared to 1 meter north. I'll put a positive symbol there. Okay? Now, the reason why we add or include these negatives and positives is when we're dealing with vector addition, it's going to be a lot easier if we all just agree that left and down are negative and right and up are positive. Trust me. All right, moving on. Okay. So if we were to take a look here at the examples, we can see that 200 newtons to the right plus 300 newtons to the right equals a total of 500 newtons to the right, right? I mean, that's easy. 200 plus 300 is equal to 500. Now, if we were to do something different, for example, if we were to try to figure out the displacement or the F net, the net force of two forces going against each other, like 400 newtons to the right and 300 newtons to the left, and we want to figure out what the remaining force is, all we have to do is add the two together. Okay? Now, you might be scratching your head and be saying, Mr. Lee, if we add 400 plus 300, we should get 700, but remember what I just said. Anything going to the right is positive, and anything going to the left is negative. So 400 plus negative 300 is, in fact, 100. Okay? Same thing goes to here. We have 250 newtons going to the right and 250 newtons going to the left. And of course, going to the left means it's negative. Put that negative there. You add the two together and you get 0. Good. Now, some of you might be scratching your head and you might be asking, Mr. Lee, can we add 200 newtons to the right and then add 300 newtons going up? I'm going to tell you no. Here's the reason why. Anything going left and or right is on the x-axis. Anything going up or down is on the y-axis. Here's a rule of thumb. You can't add x's to y's. It just doesn't work. All right. Alright, next slide. If you're trying to add x's and y's, for example, if I tell you that I go 20 meters north and then I go 50 meters to the east, and I want you to find the vector or the displacement between the two, then you're going to have to add the two vectors. And in order to do that, we have to use the Pythagorean theorem, as denoted in this example. We'll get more practice in with this in another video. Alright, so this is the end of the introduction to scalars and vectors. Okay, so that brings us to the end of the scalars and vector video. Now let's do a quick review and go over which one's a scalar and which one's a vector. Alright, length. Alright, so for example, if I were to tell you that a piece of paper is 20 centimeters to the left, does that make sense? No, it doesn't make sense. So is that a scalar or a vector? A scalar! Good! I know you guys were all saying it at home. Alright, how about force? if I were to tell you that I am pushing to the right, does that make sense? Of course it makes sense. That's what we call a vector. Now, what about speed? If I were to tell you I am traveling 20 meters per second, is that okay? Of course that's okay. That's why it's a scalar. Compared to, get ready for this, 20 meters per second west. That's a vector. But that's not speed. That's actually velocity. Temperature. If I were to tell you outside is 98 degrees north. Nope. Scalar. If I were to tell you that you have to be asleep by 9 p.m. left. That is most definitely a scalar. So that is the end of the video.
Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! With both direction and magnitude.